Hello everyone, I would like to talk to you for a few minutes about arithmetic sequences. Arithmetic, that comes from the word arithmetic, and it means basically adding and subtracting, so the easy stuff. There is another type of sequences. There are geometric sequences. And we will talk about those in a different video. Today we're just going to focus on the arithmetic sequences. So before I start teaching you stuff, let's just look at this sequence of numbers. What number comes next? Right, that was pretty easy, right? We know that 11 comes next, and then after that 13, and after that 15, because we're just counting up the odd numbers, right? If we wanted to add these together, like if we wanted to do 1 plus 3 plus 5 plus 7 plus 9, then we would use our summation notation, where I equals 1, 2, 3, 4, 5. I starts with 1 and it goes to 5, and then we would have our equation here that helps us figure things out. And it's not as easy as you might think. We're going to take the I and we're going to add to it I minus 1. So if I were to rewrite this nicely, it would be I equals 1 to 5 of 2I minus 1. And that would be the formula to add all of those together. Now you might think, where in the world did that come from? It's okay, we'll get to that a little bit later. I just wanted you to see that we would use summation notation if we wanted to add all of these together. But if we just wanted to look at them and admire them, we would not use summation notation, because this means that we're going to add together all of these terms. Okay, let's do another one. Well, I guess we're not really doing anything. Let's talk about another one. How does that sound? Take a look at this sequence. What number comes next? Well, hopefully you realize that 85 is what comes next. We're just counting up by 20, right? We started at 5, but then we add 20 to get 25, and we add another 20 to get 45, and we add another 20 to get 65. So here we're going up by 20 each time, right? So we're adding 20. Here, we were adding 2, right? We were adding 2. As long as you're going up or down by the same number each time, that's what makes it an arithmetic sequence. Okay, so as long as you're moving up or down by the same amount each time, in other words, the distance between these terms is always the same, that's how you know it's an arithmetic sequence. Okay, and now this one, if we wanted to add them together, 5 plus 25 plus 45 plus 65, then we would use our summation notation, 1, 2, 3, 4. And it is ugly. It's 20I minus 15, which I do not expect you to be able to calculate on your own at this point. But again, I want to point out that this would be if we're adding them all together. If we're not adding them all together, we need to come up with some different notation. And that is what we're going to learn now. So, the mathematicians of the world make it sound awfully complicated. They talk about the general term of an arithmetic sequence. Now, don't be scared by this. This basically means the equation for the sequence. That's all we're talking about. Sequence. It's just the equation for the sequence. And it looks intimidating. Let me show you what the general term of an arithmetic sequence is. It's A sub n equals a sub 1 plus parentheses n minus 1 times d. What? Yeah, that's what it is. You should write that down in your notes because we're going to use that over and over and over and over again. And while you're writing that down, I'm going to get a new piece of paper. And I'm going to write it up here again for you. A sub n equals a sub 1 times, a sub 1 plus n minus 1 times d. That's a 1. Okay? So this is our general term. General term of an arithmetic sequence. Okay, excellent. So let's go back to the equation or to the sequence that we had a few minutes ago. 1, 3, 5, 7, and 9. We're going to say that the first term is 1, the second term is 2, the third term is 3, the fourth term is 7, and the fifth term is 9. This should look very familiar to you because this is similar to what we did when we set I equal to those numbers, right? When we were learning our summation notation. Well, this is n equals those numbers. It's the same thing as I. It's which, what place does it have in the sequence? Is it the third place? Is it the fifth place? Is it the 99th place, right? It's the place in the sequence. And so what we can do is we can use this formula to figure out the next term. Now you and I already know that the next term is 11, but let's pretend that we don't know that. Let's pretend that we are not well caffeinated, not feeling super smart, kind of tired, and we cannot look at that sequence and know that it's 11. No worries. We can use our general term to calculate that that is 11. So let's do that. So we're going to say a sub n, in other words, the sixth term of this sequence, because that's what we're trying to figure out is the sixth term, equals a sub 1, meaning the first term, which is 1, plus n minus 1, so we're looking for the sixth term, so that would be 6 minus 1, times d, which is the distance between the terms, which is 2, right? Because we're counting by 2. So a sub 6 equals 1 plus 5 times 2. Which is 1 plus 10, which is 11. So it turns out, surprise, surprise, that the sixth term is number 11. Isn't that lovely? And now you're thinking, why do I have to know this? If I can just look at this series and I know that this is going to be an 11, why is it that I have to learn this whole complicated thing? Well, what an excellent question. I'm so glad you asked it. What if we looked at this term right here and I wanted to know what the 1372nd term is? That's what I want to know. How are we going to figure that out? Well, we're going to use our general term. So we're going to say a sub 1372, because that's the term that we're looking for, equals a sub 1, which in this case is 1, plus n minus 1, which would be 1372 minus 1, times d, which is the distance between the terms, which in this case is 2. So that's going to be 1 plus 1371 times 2, which is, I don't know, we have to do it, 1371. Hello. 1371 times 2. 1 plus 2742, which will give me 2743. So the 1372nd term of this sequence is 2,743. Yes, I could have sat here for a very long time and just counted it all out, but clearly this is much faster. So that's one of the big advantages of the general term of an arithmetic sequence. Let's do one more example. Let's take a look again at this sequence that we worked on already. Remember, we said that we had 5, 25, 45, 65, right? Our ends here equals 1, 2, 3, 4. So the first term is 5, the second term is 2, the third term is 45, the fourth term is 65. And let's say that we want to figure out the fifth term. That's what we're trying to do, is figure out the fifth term. And let's pretend that we can't just look at it and know. What are we going to do? Well, we're going to use our general term. We're going to say a sub n equals a sub 1 plus n minus 1 d. That's what we're going to say. And so we're going to say, all right, we're looking for the fifth term. So a sub 5 equals whatever a sub 1 is, which is 5, plus 5, because that's what we're looking for, 5 minus 1 times, what's our d? Well, our d is 20, right? Because these are all 20 apart, times 20. So our fifth term would be 5 plus 4 times 20, which is 5 plus 80, which is 85. So we know that our fifth term is 85. Ta-da! Isn't that great? Yes. And you're saying again, that's so easy. Let's say that I want to figure out the 118th term of this series, the 118th term. How would I do that? Well, I would say a sub 118 equals a sub 1 plus n minus 1 times d. And then we're just going to fill in the numbers. A sub 1 we know is 5 because that's what our first term is. This is going to be 118 minus 1 times our d, which is 20, right? That's the distance between the terms. So that's going to be 5 plus 117 times 20. Make sure you do this part first, right? Because order of operation says we do multiplication before we add. So 117 times 20 is 5 plus 2340. So our answer is 2345. That is the 118th term of this sequence. So that is what you need to know about arithmetic sequences. A to the n is the term you're looking for. A to the 1 is your first term. And d is the distance between the terms. All right, make sure you have that in your notes. You will use it a lot.